Higgs boson,
चंद्रशेखर लिमिट,
string theory,
न्यूट्रिनोस,
quantum entanglement.
कुछ समझा क्या?
Ever felt bored and confused while reading lengthy physics textbooks or articles?
Yeah, on God, bro.
I'm Arnav,
And I'm Pratham.
and welcome to Quark Talk, where we decode all the complexities and simplify these intricate concepts in physics.
They may have seemed too complex to understand until now.
Welcome to the first episode of the special series Philosophysics.
Where we combine, you guessed it, philosophy, physics, and STEM in general.
Pratham, think about just any random number.
3,372.
That's so random. Or is it? What does it actually mean to be random?
Today, let's stop being random and let's become ran smart.
Bro, that was your worst one yet, yaar.
Someone has to make these Dadaji jokes now.
Leave it. Now, if something is unpredictable and contains no recognizable patterns, we call it random.
Let's take an example of a coin toss or a dice roll. Coin flips and dice rolling are not intrinsically random. They're only random because of a so-called skill issue on our part. But if we could know every initial condition, the exact forces, and the properties at play for a particular flip or roll, we could theoretically calculate the result before it even happened.
And sure enough, researchers have built coin flipping robots that can precisely control a flip to get the result they want 100% of the time. So here's our question. Is there anything you couldn't predict even if you knew everything? A process determined by nothing? And how can you be sure that there aren't any patterns in what you're looking at? Like maybe you haven't even looked at it. Maybe you're not looking for the right pattern yet, or maybe you've already seen the randomness but didn't recognize it because you didn't look at it for long enough.
As if protected by some sort of camouflage, a random process can and will occasionally produce patterns.
Yeah.
Consider YouTube URLs. They are pretty much random, and a unique one is generated for every uploaded video. But sometimes, like the proverbial monkeys typing away on typewriters,
That can literally produce all of Shakespeare's works in their entirety, like just randomly.
yeah, YouTube generates a URL that contains by chance a meaningful word.
The point is, randomness is difficult to identify. It's easier to be certain that something is not random than to be certain it is.
So there is this site called random.org, and it uses atmospheric pressure noise to generate random numbers. This noise is extremely hard to predict, but technically it's still a deterministic system. All that noise comes from somewhere, and if we could figure out its initial conditions, we could theoretically predict its outcomes.
And if we want a system more random than that, we need to find one that's determined by nothing. For that, let's look closer.
Quantumly close.
Quantum mechanics may have our answer. It describes the properties of quantum-sized things as probabilities, like a probability wave, right?
Yeah.
So not because we don't know enough yet to be certain or to predict, but because, well, the idea is that there is nothing to predict. There is no beforehand you could know.
Whether a particular radioactive atom will decay or what the spin of an electron is can only be known once we observe it.
Yeah, exactly.
These events are determined by a deep-seated randomness woven into the universe itself.
So what you're saying is, what will happen tomorrow is not random?
You mean it's at least somewhat predictable, right?
Yeah, exactly, but not entirely predictable. Some things will happen for certain and other things definitely won't.
Like,
For example, the sun will rise, water will still freeze at 0 degrees Celsius, and an asteroid won't crash into Earth. Just kidding, the last part. That might happen, we don't know.
but why do we know these things?
Because everything in the universe is made up of 12 fundamental particles, and they interact in 4 very predictable ways.
Yeah, those 12 particles, we've already talked about them in our first episode,
What
is
are quarks? What are quarks? Yeah.
But what if I could determine the positions and velocities of every single one of those 12 fundamental particles in the universe?
Then you would literally be the intelligence envisioned by Laplace, like the same guy that invented Laplace transformation and all that.
Yeah.
So he thought that if you could figure out where everything is and how fast it's moving, you'd know the entire future of the universe. You'd understand how every particle interacts with every other particle.
Wow, so nothing would be unpredictable, which means nothing would be random.
Exactly, not even human behavior.
Wait, why human behavior?
Because we are literally made up of the same fundamental particles that everything else in the universe is made up of, right? Everything we'll ever do or have ever done would be determined by the state of the universe at every given moment.
That's
At any given moment.
unsettling. But doesn't that mean that every decision we make is just a result of how particles interact?
Yeah.
Where does choice or meaning come into that?
That's where information comes in.
Information? How does that fit into this?
Think about it. information is fundamentally about order, right? How things are arranged. Because if it's random, you don't know what it is. Like random, if I just say X, X, Y, Y, Z, Z, that's just a random bit of that's random information. Doesn't provide you any. That's a random bit of strings that doesn't provide any information. But for example, the molecules in a DNA, like the double helical structure of your DNA with its A, T, G, C strands, that order contains the information that makes you who you are.
So the patterns in the universe, basically, like the ones that determine our decisions, are also a form of information.
Exactly. It's not just randomness, it's the specific order of particles and interactions. And these patterns, wherein DNA or bits and zeros and ones on the laptops, or even in the words we use, carry meaning. Fundamentally, it's about like the order and regularity, and it's tied to how everything in the universe evolves.
So the same concept of information that explains how a video plays or a sentence makes sense also explains how our choices come to be.
Precisely. Information connects the particles and the patterns, linking the microscopic world to the macroscopic one, including us.
But does every letter in a word contain the same amount of information?
No, not really, right? If you think about it, let's assume you have the letter Q. After that, you almost always know the next letter will be U. And after a TH, there's not always, obviously, but probably going to be an E.
So those letters don't carry much information since they're predictable.
Exactly. Most of them are redundant. In fact, Claude Shannon, the founder of information theory, suggested that English, which is like the world's most spoken language, has about 75% redundancy.
That's why we can still make sense of things like this sentence is messaging some letters, right?
Missing some letters.
Same thing.
Exactly. English can be compressed because it's not random. It has patterns.
Similarly, this video or this podcast, whatever you're listening to, it's also compressible because of its regularities.
Regularities? Like what?
Well, in each frame, the frequencies of what we are saying, they tend to cluster together, and from frame to frame, most of the frequencies don't change. So you only need to record the ones that do change.
So that's interesting. You can use that to like do whatever you want, right? So let's say you have a video. So we can use the same thing what you did for you gave the analogy of our video podcast or of our audio podcast, right?
Yeah.
So if we had a video podcast, that's the same technique behind data moshing. When you apply the movement data from one video frame to the pixels of another video frame, or another video.
Cool. So how much can you even compress a video or an audio file, whatever it is?
So an average video can be compressed to just 1,000th of its original size. I think MKBHD had done it, right? He re-uploaded the same YouTube video 1,000 times. He's done that with YouTube Shorts also and YouTube, the long form video as well.
But what's the limit? How much can you compress something though?
Well, anything that isn't random, anything with patterns or regularities like a YouTube video can be reduced because it's predictable, and you can keep shrinking it until you're left with is totally random.
Wait, random?
Yeah, that's what we call pure information. So whatever you had information that wasn't random at all the information of the original file is there, but it's distilled and it's pure randomness.
So pure information is randomness.
Exactly. So the more random something is, the more information it contains, and randomness is disorder. Entropy.
What?
Yeah. So information fundamentally is entropy.
Right. Think of it as a string of binary digits. Here's an example. The string, suppose happy, is perfectly ordered, so it has very low entropy.
That's like an erased hard drive, right? No information, just all zeros. So there's 0, 0, 0 everywhere. Just very easy to explain, right?
Yeah.
Like the least amount of information is 0, 0, 0 or 1, 1, 1, 1, all the same.
I see. So the string with maximum information would be?
Something that's completely random.
So maximum entropy, totally disordered. You couldn't predict any digit by looking at the others, and there's no way to compress that at all.
Exactly. You'd have to send the whole thing as it is, right? No shortcuts, no wrap. There's no way to compress it at all.
But here's the thing. Objects with maximum information carry no meaning for us.
That's true because they're totally random. But here's the thing. A video with maximum information would just be white noise. Every pixel's color would be independent of the others and would just change randomly.
And you couldn't compress it because it's already totally random.
Right. A random sequence of DNA, for example, wouldn't make an organism. And a random string of letters wouldn't make a word. Like they could, but very, very, very
Yeah.
unlikely.
So we're drawn to things that are in between, neither perfectly ordered nor completely disordered.
Exactly. Somewhere in the middle, where we recognize complex patterns, is where we find meaning. In music, poetry, ideas.
And even science,
Absolutely. So scientific theories are like our way of compressing the universe.
like general relativity, like one equation itself explains so much. Apple falls, or rather they don't. Planets orbit, black holes form, and the universe expands.
So does that mean the universe is completely predictable finally?
Not quite, right? If Laplace were right, and knowing that the state of the universe at one time meant knowing it at every other time, then the information in our universe would be consistent and constant.
No, but that's not the case, right? Because the second law of thermodynamics says that entropy increases over time.
Correct.
And we've spoken about in episode 3 or 4, whatever, what is entropy. So things don't actually stir themselves apart, right? Because entropy is increasing.
Yeah, so if entropy is increasing, then the information in our universe is also increasing.
Exactly. It takes more information to describe the state of the universe currently than right after the Big Bang, for example.
Yeah, but where is all this new information coming from?
Probably quantum mechanics.
Quantum mechanics?
Yeah, it describes how the 12 fundamental particles behave, as we said earlier, right? But as successful as it is, it's only a probabilistic theory.
Meaning we can't predict exactly where something like where an electron would be.
Yeah, we can only calculate probabilities, like as I said earlier, probability wave, right? When we interact with the electron and locate it, we gain information. Something we couldn't predict with certainty beforehand.
That must have driven Einstein crazy, right?
Yeah, it did. He famously said, God does not play dice with the universe. And he literally wished for a theory that could predict everything with certainty.
But maybe quantum mechanics can't be compressed further because it's fundamentally random.
Exactly, and randomness is where new information and new questions come from.
So fundamentally, new information is being generated every time a quantum event occurs.
Exactly. And if that's the case, these quantum measurements could be driving up the entropy of the universe.
By creating new information all the time.
Exactly. And that also means that disorder in a universe must increase, which is what we observe in the second law of thermodynamics.
You know, we often think about the second law as a curse.
Yeah.
Like everything ordered is inevitably heading towards disorder.
True, but maybe it's not a curse, right? Maybe it's only in a universe where this law is obeyed that the truly unexpected can happen.
Huh. So you're saying that the second law makes it possible for the future to be actually undetermined.
Exactly. For us to have like free will truly, we really need the second law of thermodynamics.
But aren't quantum events too small to have any meaningful impact on the evolution of the universe?
Not at all. There are physical systems like the triple pendulum, or you can say quadruple pendulum also, whatever. Double pendulum as well. But the point is, they are so sensitive to the initial conditions that even a tiny change in the initial conditions can lead to a big difference over time.
That's chaos, right? Chaos theory, the butterfly effect.
Exactly. And also like the three-body problem which you spoke about.
Yeah.
Literally that. So and you and I could also be such systems, chaotic systems.
So our free will could come from quantum events happening in our brains.
Yeah. And that's the idea. It seems like we live in a universe where the future isn't fully determined, where it's at least somewhat random.
That's fascinating. Randomness might actually be the key to free will.